Okay, so let's go through an example, and we're going to find the 4 things that I mentioned in the other video. Okay, so let's try the example of y equals, let's say, x squared minus x minus 12, okay? So this one, we can't really tell whether it's been shifted left, right, up, down, whatever. So we're going to find those 4 things one after the other. So the first thing is the orientation. So that is determined by the value a, which is the number in front of x squared. So you can see if nothing's written in front of x squared, remember it's 1. So the a value here is 1, which is definitely greater than 0. So this will be a smiley face. Second, to find the y-intercept, you let x equals 0, so then find the y value. So y would be 0 squared, because x is 0, minus 0 minus 12, which is, of course, just minus 12. So that's the y-intercept. X-intercepts, remember, you have to solve that quadratic equal to 0, or you let y equal 0. So I've got 0 equals x squared minus x minus 12. Now this is a quadratic trinomial. So remember, the way we solve them is we factorise by finding 2 numbers that times to this and add to this. So I want 2 numbers that times to negative 12 and add to negative 1, and they are, of course, minus 4 and positive 3. So I've got that equals 0. Okay, so that's my factorisation there. If 2 things multiply to 0, either the first thing equals 0, in this case that means x equals 4, or the second thing equals 0. In this case that means x is minus 3. So this will have 2 x-intercepts, one at x equals 4, one at x equals minus 3. The last thing to find is the turning point, and we use for that the equation x equals minus b on 2a, and that also gives us the axis of symmetry. So remember, b is just the number in front of x, a is the number in front of x squared. So in this case, b is negative 1, so we'd have minus b over 2 times a, and if you're worried about the negative signs here, just put that in your calculator. You get x equals half. So then what we do is we substitute that in to find the y coordinate. So y would be half squared minus a half minus 12. And that gives us minus 12.25. Now, because a is greater than 0, remember this turning point will be a minimum. Now we have everything we need to graph it, so I'll do that on the next slide. Copy down any of this if you like. Okay, so now we will graph the quadratic on the previous page, and we know that it will look like a parabola. It's a parabola. So we had 4 things. So we know that the orientation is going to be this way, because a was greater than 0, and then we're going to mark the x and y intercepts. And then we're also going to mark the turning point. So if each of these dashes is going to represent 1, so this would be, minus 1, minus 3, and so on. So we'd have minus 5, minus 7, minus 9, minus 11. Minus 12 would be down here, and this is the y-intercept. So we found out on the previous page that the y-intercept was minus 12. We found out that the x-intercepts were minus 3, which would be over here, and 4, which would be here. Now the turning point, or axis of symmetry, was at x equals a half, so you don't have to be like really, really close to it, just, close enough is good enough. So x equals minus a half, sorry, it was x equals positive a half would be here. And the y value of the turning point was minus 12.25. So minus 12 we know is here, that's the y-intercept. So minus 12.25 would be about down here. So this here is the turning point. So now we have enough to graph this. So we know it's going to look like this shape here. So turning point is also the axis of symmetry, and we draw a curve up to the x-intercept there. And then we also do the same here. Again, sorry that my drawing is a bit rough. And that is the graph of the equation that we looked at on the previous slide. Y equals x squared minus x minus 12. So we've got all the features that we need. Also note the turning point is the axis of symmetry. So I know my drawing is a bit rough, and I apologise again for that, but this here should be the axis of symmetry. The line x equals a half. So it should be symmetrical about that. The actual parabola is just not evident from my diagram. Okay, well I hope you've got something out of this video. This has been the luckiest maths teacher in the world. Have a great day.